Now, the next thing we are going to look at is, the next method we are going to look at is completing the square method. I told you that we have different methods of solving quadratic equation. We have the factorization method, the completing the square method, and the standard formula method or quadratic formula method. Let us see how we can use completing the square method to solve quadratic equation. Now, looking at the board, the equation of the form x plus p all squared is called a perfect squared. Look at it. X plus p all squared is called what? A perfect squared. How do we show that it's actually a perfect square? Now, we're told that the expression is what? X plus p all squared. So this expression is saying x plus p bracket x plus p. So I can open the two brackets. So it is still the same thing with this expression we have here. If I expand these two brackets, x times x gives me x squared. X times p gives me xp. P times x gives me xp. And p times p gives me p squared. This will give us x squared plus xp plus xp will give us 2xp. And then plus what? P squared, okay? If you look at this expression is equal to this expression here, x plus p all squared. So that is how perfect square came into play there. So you can see what is going on there. So now, there's something you need to know about perfect square. You recall that your discriminant d is equal to what? Square root of b squared minus 4ac from your standard formula. If I square both sides, now squaring both sides, I have d squared equal to square root of b squared minus 4ac all squared. So that means d squared is equal to what? B squared minus 4ac. So this, because of the square root disappears. Now your d squared is equal to what? D squared is equal to b squared minus 4ac. If we set d to be equal to 0, when your discriminant is equal to 0, in that case, the equation becomes a perfect square. So if d is equal to 0, I fix d as 0 squared equal to b squared minus 4ac. So that means 0 squared will give you 0. Automatically you have b squared minus 4ac is equal to 0. If I want to have a proper rearrangement, I can just say that b squared, I transfer 4ac here because it's negative. It becomes b squared equal to 4ac. This condition holds if the equation is a perfect square. B squared equal to 4ac, it holds if the equation is a what? Is a perfect square. So this is what we use to solve for perfect square questions. So let us see how we can apply this formula. Now let us apply what we have just proved to this question we have on the board. What must be added to the equation x squared plus 5x to make the expression a perfect square? So what must be added? Now let us see what must be added to make that expression a perfect square. Solution. The equation given to us is x squared plus 5x. Let's assume that what must be added to it is maybe k to make it a perfect square. So I'm going to look for my k. That means in this expression now, it's k I'm looking for. Already I've told you that for an equation to satisfy a perfect square, the formula you are going to use is b squared is equal to 4ac, okay? From the equation you have originally, the coefficient of x squared is 1. So that means a is equal to 1. And the coefficient of x here is 5. That means your b is equal to 5. Then your c is equal to what? K. So if we substitute it into this expression for a perfect square, which is b squared equal to 4ac, we have b squared equal to 4ac. So we have 5 squared is equal to 4 times 1 times k. So 5 squared is what? 25. And 4 times 1 times k will give you 4k. So that means k is equal to 25 over what? 4. So this implies that the equation becomes what? X squared plus 5x plus 25 over 4. So this is what must be added to the expression to make it a perfect square. I believe you understand what I've just done. So this is the simplest formula you can actually use. Even in JAM, in WAEC, it's going to help you. Okay, now we have example 1.2 on the board. What must be added to y squared plus 1 whole number 1 over 2y to make it a perfect square? Solution. So this is y squared plus 1 whole number 1 over 2y. So what must be added? Let's call it g. So if we call that g, so we are going to look for g at the long run. So now the coefficient of y squared here is 1, so it implies that a equal to 1, and the coefficient of y here is 1 whole number 1 over 2. So I can just simply change that to 3 over 2, because if I change it to improper fraction, it becomes 3 over 2. So it therefore means that your b is 3 over what? Over 2. Therefore your what? Your g will be equal to what? So our c is equal to g, okay? So if we do that, the equation I gave you was b squared equal to 4ac for perfect square to hold. So I'll fix my b here. I have 3 over 2 all squared is equal to 4 times your a, which is 1, and times your c, which is g. So that gives me what? 3 squared is what? 9. And 2 squared is what? 4. So this is 9 over 4 equal to 4g. So this is 4g over 1. If you cross multiply, you have 4 times 4g, which is equal to what? 9 times 1. So if you multiply that, you have 16g is equal to 9. So your g becomes 9 over 16. So that's our final answer. So for you to have what you are going to add to it, it becomes y squared plus 1 whole number 1 over 2y plus 9 over 16. 9 over 16 must be added to make the expression a perfect square.